Hello everyone. So this is another PYMT question. This time the question is from Binomial theorem, and in particular it is based on Lucas theorem, as you can see. And the question tells that find the remainder when this 525c to 58 is divided by 11. So I suggest that you should try this question first. And of course you know the meaning of this NCR. NCR is n factorial divided by n minus r factorial into r factorial. So if you solve it correctly, the answer should be 7. Now, how do we understand this question, means why the Lucas theorem is important there? We will see it. And the challenge for me is I don't use any statement of the Lucas theorem, but I simply solve the question directly by using only the binomial concept, and suddenly we will realize that this is coming by the Lucas theorem. So let's see here, and we start from the basic, and the basic I have taken the remainder we have to find of 13c7 when divided by 5. So the idea emerges or the starts from here. Suppose I have 1 plus x to the power 13, and in that I am looking for the remainder of any 13c7 coefficient. So what I'm going to do, I'm writing this 13 because I have this 5 there. So I'm writing this 13 as the base of 5. The base of 5 meaning that I want to break as many factors of 5 to get into the 13. So all the bases should be 5. So we can write this 13 as 2 into 5 and plus 3. Because this 13 is a 2-digit number, so there is no such any 5 to the power 2 or anything 3 will come. Now this I can write as 1 plus x to the power 2 into 5 and plus, not plus, product 1 plus x to the power 3. Now the entire concept is relying on this, because you notice that if I have 1 plus x to the power 10, I can write this as 1 plus x to the power 5 and the whole power 2, and that is 1 plus x to the power 3. Now let's try to understand how this 5 is coming out, means how many terms we are getting the multiple of 5 and how we can simplify it. So the simplification goes like this. You can notice that if I want to write this entire expansion inside this I can write directly as 1 plus 5 times some lambda plus x to the power 5 and the whole power 2 and 1 plus x to the power 3. Now what I mean to say that 5 lambda, because you notice when I apply the binomial theorem over here, every term except this 1 and this x to the power 5, every intermediate terms between this first and the last term are multiple of 5. And the 5 is a prime number. By the way, I tell you that this Lucas theorem works only if the divisor is 5 there. Means divisor is prime number there. So what will happen if the composite number over there? We'll see again, but let's see first this one. Now notice that what I can do now, that I can write this 1 plus to the power 5 and plus 5 lambda again the whole square. And this time you notice that it doesn't matter what the power is this, because again the second term I have this thing multiple of 5, and I'm applying once again the binomial theorem over here. So what I'm getting is 1 plus x to the power 5 the whole square plus 5 lambda times 2 into this 1 plus x to the power 5 and again 5 lambda to the power 2, and this thing we are multiplying with 1 plus x to the power 3. Now what will happen to it if I multiply this thing there? You can notice that this is already divisible by 5. This is already divisible by 5. So what I'm left with is 1 plus x to the power 5 2 into 1 plus x to the power 3. By the way, I mean to say that this I'm going to find out the modulo of 5, means mod 5 means I'm finding the remainder when the entire thing is dividing by 5. So this is equivalent to mod 5 again, and means are you looking for the 1 plus x to the power 13 modulo 5 means are you in a search of remainder when you are dividing 1 plus x to the power 13 with 5. It is equivalent that you are looking for the remainder when you are dividing this quantity by 5, or it is equivalent when you are dividing this quantity by 5 and so on. So you can notice that these terms are already multiple of 5, so I have the equivalent thing in such that this is mod 5 again. It simplifies to what? That if I'm looking for x to the power 7, it means I have the coefficient here 13c7. And the same thing equivalently, if I'm looking for x to the power 7 over here, I will get the same mod 5 because I'm looking for the remainder dividing by 13c75 on the left hand side. The same thing, if I find the coefficient of x to the power 7 here and I divide that quantity by 5, I will get the same remainder. So the meaning is this one, that I am intended to find out the remainder of the 13c5 from there. So means that I'm looking for the coefficient x to the power 7. So I'm writing the general term of the first term, that is what, 2cr1 and x to the power 5 times x to the power 5 to the power r1, and the second expansion have the general term as 3cr2 and x to the power r2, and when I combine them together this will become 2cr1, 3cr2 and x to the power 5r1 plus r2. And now you can realize that if I need to have this thing as 7, I must have 5r1 plus r2. And now look at this one, how beautiful it is, because this side, when I wrote this 13 there, I wrote this 13 as the base of 5, and in there the 7 is also looking for the base of 5. It means I again have the base of 5 for 7, so I will have 5 into 1 plus 2 into, let's say, 5 to the power 0. It means the coefficient what I'm getting over here is this one, at the place the value of r1 is 1 and the r2 is 2. So let's substitute it there. So it means the mod 13c5, 13c7 is equivalent to 2c r1 is 1 into 3c 2 mod 5. Means when we are finding the remainder of 13c7 when we are dividing by 5 is equivalent to find the remainder of 2c1 into 3c2 divided by 5. Now the beauty of this thing is, you'll notice that what we have done there, this 2 and 3 are coming from the what we call the coefficients, or we can say the factors, or like I have done this 13 and 13, I have written that what, 5 and plus again 5 to the power 0. So that's why it came 2 here, and then that will come 3 there. So this 2 and 3 is coming from there when I wrote this 13 as a base of 5. In the similar way, this 1 and 2 is coming from the similar kind of operation we are going to do on 7. It means I have this 7, and 7 I'm writing again with the base of 5, that is going to be 1 this time, and that is going to be 5 to the power 0, so that is going to be 2 this time. So this is 1 there and then 2 there. And what we are doing, we are just taking this 2 and 1 and 3 and 2 as numbers to make the binomial, means binomial coefficients. So 2 and 3 are coming at the subscript of this binomial, and 1 and 2 are the coming as superscript when I write it like this. So like vice versa, that 1 and 2 are coming as subscript and 2 or 3 are coming as the superscript. Now let's find it out. So what we get it here, 2, and that is going to be 3c2 is 3, so 6. So when I'm dividing this thing by 5, that will be 1. So remainder is going to be 1. And if you want to calculate it, 13c7, and whatever it comes when you divide by 5, you will get this thing as a proof. Now the similar thing we are going to do in this one, in this particular question, So I have this time 525 C 258. So understand better, let me again do, but you know the idea. The idea is very simple. If you want to find, I have to write this 525 as 11. So 11 square, because the nearest power of 3, because if you take one, no, not 11 square. Yes, 11 square. 11 square is 121. If you take the 11 cube, it will exceed 525. So 11 square, and plus again I'm writing 11, and again plus again I'm writing 11 to the power 0. Similarly, I have to do 258, and that is going to be here 11 to the power 2, 121, and plus again 11 to the power 1, and plus again 11 to the power 0. All that we have to find out this thing. So I have already calculated. Let me just write it. So that is coming as 4, because 121 times 4. And then, okay, I will also tell you how to calculate it. So this is a 525 there. So let me just divide by 11 square. So 11 square is 121. So times 4 you do, that is going to be 4, and this is 484. Now this 41 I'm dividing by 11. So that is going to be 3, and that is 8. And after that, there is no divisibility by 11, means this 8 is lower than 11. So I have this thing 4 and 3 and 8 I'm writing there. So that is 8, sorry, yeah, the 8, that is 3. So this way we got the upper parts like a 4, 3, 8. And here what we do, again we divide 258 by 11 square and so on. So what I'm getting here is 2, and then that is 1, and then 11 to the power 0, there is 5. So this way we got, and what is the answer? There is a 4C2 into 3C1 into 8C5 and modulo 11, means whatever remainder comes when we are dividing this quantity by 11. So 4C2 is going to be 6, 3C1 is 3, and 8C5 is going to be 56. Yes. Now notice that 55 is a number which is very close to the multiple of 11. So I can write it as 18, and that is 55 into 1. Sorry, 55 plus 1, not into 1. And then I can separate it. So 18 into 55 and plus 18. So this is again multiple of 11. So I have to only find the remainder when I'm dividing 18 by 11. That is going to be 7. So 18 modulo 11, and the answer is 7 we got. So this way we got this answer. We want to look into that. Of course we can think in this way, that suppose I have 1 plus x the whole power 525, and of course I have to write this thing in that way. So we write here 1 plus x, and the first thing we write here 4 into 121 and into 1 plus x, 3 into 11, and into 1 plus x to the power 8. And of course this thing I'm going to write as 1 plus x to the power 121, because 11 factor I'm taking here, sorry, 11 multiple, and that is going to be 1 plus x to the power 11 again, and to the power 3, and 1 plus x to the power 8. And now what I have to do, here you can notice that this is effectively I have to write as 1 plus x to the power 121 to the whole power 4, because whatever expansion if you do, the intermediate terms are already multiple of 11, and when you multiply this whole quantity with this two terms together, again that factors will be multiple of, that terms will be multiple of 11. That is redundant, we are not going to use it. Similarly here I can write as effectively 1 plus x to the power 11 to the power 3, and here I can write 1 plus x to the power 8. And now we are looking for the coefficient of 258, perhaps 258, yes. So 258, so this side I'm getting here 525 C 258, and equivalently we are getting here. So first I write this thing as 4 C R1, and x to the power 121 into R1 into 3c R2, x to the power 11 into R2, and 8c R3, x to the power R3. And now you notice that if I combine all these powers, we get the sum must be what? 121 R1 plus 11 R2 and plus R3. It means I can write as 11 square plus this is 11 and this is again that is again dash 11 to the power 0. It means we are again finding out the basis of 11, that is coming out to be 215. There is no such other combination we will have, and therefore we are going to put those values there, there and there, so this way it works. And this is the Lucas theorem. If you want to generalize it, of course we can make the prime number like p, and from there we can generalize this whole thing, but it's not important, or it's not so difficult to generalize also. So the only thing that you understand the process the way we are thinking, it's also not so difficult to understand this way. Now the question for you is, what will happen suppose you want to find the remainder of 525 C 258 when we are dividing by, let's say, 21. It means this time this 21 is not a prime number, is a composite number. What will happen? So idea I'm just giving to you, you can to work, and if you need some other detailed video when the prime numbers are repeating and all, then you just leave a comment, but that is sufficient, I feel. So what I'm going to do is the idea is this one. If you can write it as 3 into 7. Now there's 2 prime factors, so find the remainder when this is divided by 3, the prime number, and find the remainder we divide by 7, and again use the 2 reminders to find the complete remainder. And I hope you will work on it. If not, then please leave the comment. I will create a new video. So that's all for today's video, and I hope you learned new things. So see you in the next video with some other problems what I think you must try. Till then, stay math active.